Okay, this is a question I sometimes hear from students. What do I need for an A? We're going to use a simplified scoring system here. We're going to assume that all scores are weighted equally. And so if your instructor has a different scoring system, then that's going to be different. But here we'll just assume each score is equally weighted. Fatima has exam scores of 87 and 90. What is Fatima's current average? Will be, we call this X1, the first exam plus the second exam. X1 is 87, X2 is, or exam 2 is 90. So the mean would be X1 plus X2 over 2, which would be 87 plus 90 over 2. 87 plus 90, 177 over 2, and that's going to be 88.5. Okay, so oftentimes instructors use 90% as a cutoff for an A, so 88.5 would be a little bit less than an A if under that grading system. Part B, what does Fatima need on the third exam to raise her average to at least a 90% A? Okay, so now we have 3 exams, so the mean is going to be X1 plus X2 plus X3 divided by 3, and we want that to be at least 90, so greater than or equal to 90. And we know 2 of the exam scores already. 87 plus 90 plus the third exam score we don't know, but we want the average to be at least 90. So we can add the 87 to 90. We can't add the X3 yet because we don't know what that is. But we'll have 177 plus X3 over 3 is equal to greater than or equal to 90. And now we want to solve for X3, the third exam score. So we want to get the 3 out of the denominator, multiply both sides by 3. We have 177 plus X3 over 3 times 3 greater than or equal to 90 times 3. So on the left side, the 3's will cancel, and we'll just have 177 plus X3. Make myself more room here. Okay, so we'll have 177 plus X3 greater than or equal to 270. And then we're still trying to isolate the X3, so we want to subtract 177 from both sides. And on the left side, 177 minus 177 is 0. That'll drop out. We'll just have X3 greater than or equal to, and then if we subtract, this would be 93. So Fatima needs at least a 93 on the third exam to bring her average up to at least a 90. Okay. Okay, so Gardenia has scores of 97, 93. Gardenia already has an average that's more than 90, but Gardenia wants to keep her average above 90 with the third exam. So let's see what Gardenia's current average is. So X1 is 97, X2 is 93. The average of the first 2 exams, X1 plus X2 over 2, would be 97 plus 93 over 2, 190 over 2, would be 95. Okay. So Gardenia currently has a 95 average, and part B, we want to know what Gardenia needs on the third exam to keep her average at least 90% A. So X1 plus X2 plus X3 over 3 has to be greater than or equal to 90. So we have 3 exams now. And we know the first 2 exam scores, at 97 plus 93 plus x3, whatever that is, over 3 greater than or equal to 90. And 97 plus 93, since we know those exam scores, we can add those. It'd be 190 plus x3 over 3 greater than or equal to 90. And then we want to get rid of the 3. We'll isolate the third exam score. So let me make myself more room here. Multiply both sides by 3 to get the 3 out of the denominator. And on the left side, the equal sign, the 3's will cancel. And we just have 190 plus x3 plus the exam 3 score greater than or equal to 270. And then we want to still isolate the x3, so we want to subtract 190 from both sides of the greater than or equal symbol. And this will give us x3 greater than or equal to 80. So on the left side, the 190 minus 190 is 0. We just have x3. 270 minus 190 is 80. So Gardenia needs at least an 80 on the third exam to maintain her average. Okay. And just a comment about this. We say that the mean for sample size 3 has 2 degrees of freedom, because if you notice here, if we know that 2 exam scores, and we know that the mean, then we can get the other exam scores. So for Fatima, we knew 2 of the exam scores, we knew the mean, that determines the third exam score. So so that means we can choose any 2 scores we want for the first 2 scores, and we can still get the same mean. So for Gardenia, we had 87 and 90, and we're able to get a mean of 90 for including the third exam. Gardenia had scores of 97, 93. We're able to get a mean of 90 with including the third exam. So we say there's 2 degrees of freedom, because the first 2 scores can be anything you want, and you could still end up with a 90 average. Now, in some cases it might not be in an actual situation. It might be not possible to get a 90 because maybe you need maybe the highest grade allowed on the test is 100, and maybe you need 110 or something to raise your average to 90. So, apart from that limitation, the first 2 exam scores can be anything, and you could find some score that make it average out to 90. So anyway, a mean for sample size 3 has 2 degrees of freedom, and more generally, the mean for sample size n has n minus 1 degrees of freedom. And degrees of freedom are important for some of the hypothesis tests covered in Math 251. So in this exercise, we find the degrees of freedom for the mean if the sample size is 4. So 4 minus 1 answer is going to be 4 minus 1, which would be 3 degrees of freedom. So if you have if you know the mean, and you know 3 of the 4 scores, you can figure out the 4th score. The 4th score can, the first 3 scores can be anything you want, and you can still get the same mean. If the sample size is 17 degrees of freedom for the mean, 17 minus 1, which would be 16. Okay, so that concludes this presentation.